So what is the big challenge to doing serverless in the enterprise? It's control. A perceived lack of control is the number one technical challenge that stops customers implementing PaaS and serverless in the enterprise. And it's not too hard a conversation to start having with your organization though. In Australia, ASIO uses Azure for secret workloads. The US Department of Defense is putting billions of dollars into their Azure platform. We have docs on how to build web applications up to an Australian Signals Directorate IRAP protected approved architecture. We also have an architecture for financial services companies like banks that is PCI DSS certified. Banks, federal and state governments, and security organizations are trusting sensitive workloads to PaaS. In organizations that have trust issues, I find starting from a place of safety is best. That's why I love these reviewed and approved architectures. They let us have the conversation about the sensitivity of the application we're building. A good question to explore with your organization is sometimes, if banks and government departments can host sensitive workloads on PaaS, why can't we? As I tried to portray at the beginning, the issue is often how the developers introduce new patterns and technologies to an organization, often determine their success. Developers, if you want to use serverless, you need to advocate the serverless security spectrum and networking patterns inside your organization. The architects and the security team want to see, how do we apply network controls? How do we do networking and monitoring and logging? What uptime am I going to get and how much is it going to cost? So before we look at these different architectures, I just want to do a bit of a level set. What I have on the diagram here is a normal Azure function and logic app. By default, both of these are accessible from the internet as long as I'm correctly authorized. For example, I can get the URL of my Azure function and put it in my browser. This is a cause for concern for some organizations. Once again, this can absolutely be secured, but either because of regulatory requirements or else a desire to implement the same network isolation-based security policies as they have on-prem, many organizations want their web applications, function apps, and logic apps to be completely isolated from the internet. IT pros have been isolating workloads from the clouds for decades. It's what they love to do. The short version of how they do it is all websites have a numeric address called an IP address. There are a few special ranges that won't work from the internet. These are reserved for inside work and home networks. They often start with 192.168 or 10. something. For our demo, we've chosen 10.1 to start the addresses for our on-premise network. We can also create a private network space inside our Azure cloud. Let's assign this the addresses that start with 10.0. Everything inside this network has a 10.0. something IP address, and it's private and it's not accessible at all to the internet, but that is able to be connected to the organization's on-premise network. This provides additional security to our internal resources. There's no way to access our private address space from the internet. Once we have that private network space, we can start to carve it up into smaller networks called subnets and reserve some blocks of IP addresses for different purposes. I've created two here, one to put web apps into and one to put our API gateway into. We can then wrap a firewall around each subnet, allowing us to control the traffic in and out of each subnet. These tools are the security tools IT pros have been using for decades. They're familiar and they're going to bring a sense of comfort to the IT pro and security teams. Now that we have our private address spaces and we have them locked down and controlled by firewalls, we can create our web compute and API gateway resources in those subnets. Everything we need to run API management and the compute for the functions is deployed into that private address space. It's worth noting that the API gateway isn't actually an API. It's an abstraction layer over the top of the actual APIs that lets you manage security, performance, and admin tasks related to your APIs. A single pane of glass for things like auth, caching and rate limiting. Now, because these isolated services only have an internal IP address, there's no way for them to be accessed except from other IP addresses like the ones on-prem. If we did want controlled internet access to these resources, we'd put in a load balancer and firewall that straddles the virtual network and allows us to create specific rules about what traffic to allow into our private network and where it should go. We've now essentially recreated the core of the protected or PCI architectures. What we're missing from our diagram, however, is the data stores. Let's put on the Azure Storage and Cosmos from the original use case. Now, because these services are based on massive shared infrastructure, there's no mechanism to actually deploy them inside our private virtual network. What we do is instead use the private link feature. With private link, we block off all the internet access to the multi-tenant services and create an endpoint with a private IP address that becomes the only way to access that service. The services are no longer accessible from the internet, but they are accessible from our other private resources in the VNet and from on-prem. If we have a firewall, but only if we've got firewall rules configured to allow it. Private link's one of the key features to understand and advocate to enable serverless in your enterprise. It's the feature that allows us to talk to the security teams and explain that we can have network isolation of public PaaS services. It's a really big deal. This is the solution that lots of our customers start with. It gives them most control, but it's the most complex to deploy and it costs the most to run. The conversation we're having with many of our customers is how to move their web applications, functions, and logic apps out of the private network. And instead, we want to run them as multi-tenant services, but still have great network control. This is going to be much cheaper, easy to manage, and gives them all the benefits of a pure serverless solution. The challenge is now that we have secured now we have secured our data services using private link. The only way to access them is via the private network. This is where VNet integration comes in. VNet integration lets you create a subnet in your private address space, and then your applications get projected into that subnet. From this subnet, we can talk to the private endpoints for our data services. With private link, you can secure the inbound traffic, and VNet integration lets you secure the outbound traffic. Can anyone see anything that someone who cared about network security on this diagram might raise as a concern? Yeah, that's right. We've used VNet integration to allow the functions to talk to the data services, but we haven't locked them down yet. They're still in the public address space and accessible from the internet. What we've done here is isolated the Azure functions using private endpoints. Because our API gateway is in the private address space, it can now talk to the private endpoints for the functions. The functions then use VNet integration to talk to the private endpoints for the data services. And we're using multi-tenant serverless compute and storage and ensuring network isolation as well. This is really the best of both worlds.